Have you ever wondered what the last sunrise on Earth will look like? Not the last sunrise because of war, not because of climate change, not because humanity disappears, but because the sun itself reaches the end of its life. Every morning the sun rises without fail. It feels permanent, reliable, almost eternal. Yet hidden behind that comforting yellow light is a countdown that began billions of years ago. A countdown toward a future where the skies turn red, the oceans vanish, and the earth may be swallowed whole. This is the story of how the sun will die and what that means for us.
Right now, the sun seems calm, a giant glowing sphere hanging in space. But appearances can be deceiving. The sun is actually a gigantic nuclear reactor. Deep inside its core, temperatures reach around 15 million degrees Celsius. Under immense pressure, hydrogen atoms collide and fuse together. They become helium, and in the process, they release enormous amounts of energy. That energy travels outward and eventually reaches Earth as sunlight. Every second, the sun converts roughly 600 million tons of hydrogen into helium. Think about that for a moment. Every single second. Yet, despite this astounding rate of consumption, the sun is so massive that it has enough fuel to continue shining for billions of years. Scientists estimate that the sun formed approximately 4.6 billion years ago. In other words, it is currently middle-aged. If the sun's entire life were compared to a 90-year human lifespan, it would be around 45 years old. Not young, not old, just somewhere in the middle. And like every middle-aged star, the sun is slowly changing. Even today, it shines about 30% brighter than it did when Earth first formed. The change is slow enough that we barely notice, but over cosmic timescales, those tiny changes become enormous, and eventually they lead to something extraordinary.
The sun's hydrogen fuel is not infinite. Every star lives by the same rule. Burn fuel, produce energy, run out, die. The only difference is how long the process takes. Small stars can survive for trillions of years. Massive stars burn their fuel quickly and may live only a few million years. The sun sits somewhere in between. Its death won't be sudden. It won't explode tomorrow. Instead, it will unfold through a slow transformation lasting hundreds of millions of years. A transformation that begins long before the sun actually dies, and the first victim will be Earth itself. Imagine a campfire. When it starts running low on wood, it doesn't immediately go out. Instead, it behaves differently. The flames change. The heat changes. The entire structure of the fire shifts. Something similar happens inside stars. As hydrogen in the sun's core becomes depleted, the balance that has kept the stars stable for billions of years begins to break. Gravity starts squeezing the core inward. The core becomes hotter, denser, more compressed. Ironically, this compression
causes the outer layers of the sun to expand. The star begins to swell, slowly at first, then dramatically. Millions of years pass. The sun grows larger, brighter, hotter. From Earth's perspective, life becomes increasingly difficult. Long before the sun becomes a red giant, our planet starts feeling the consequences. About 1 billion years from now, the sun's increasing brightness may trigger a runaway greenhouse effect. Temperatures rise globally, oceans begin evaporating, clouds trap more heat. The process accelerates. The Earth gradually transforms into something resembling modern-day Venus, a world of crushing heat, a world without oceans, a world without life as we know it. And this happens while the sun is still technically alive. The real drama has not even begun yet. Roughly 5 billion years from now, the sun enters a new phase. Astronomers call it the red giant stage. This is one of the most spectacular transformations in stellar evolution. The sun's outer layers expand outward, far outward. Its diameter may grow more than 100 times larger than today. To understand this scale, imagine replacing the sun with its future red giant version. Its surface would extend beyond the orbit of Mercury, beyond Venus, possibly reaching Earth's orbit itself. The night sky would disappear forever. The sun would dominate everything, a colossal red sphere filling much of the sky. The familiar yellow star that nurtured life for billions of years would become almost unrecognizable, and Earth would be facing its greatest challenge. For decades, scientists debated a terrifying question. Will Earth actually be swallowed by the dying sun, or will it escape? At first glance, escape seems possible. As the sun loses mass, its gravitational pull weakens. That causes Earth's orbit to slowly drift outward. Like a ball attached to a string that suddenly becomes longer, Earth gradually moves farther away. This sounds like good news. Perhaps our planet avoids destruction after all. But then, another effect enters the story, and it changes everything. The swollen atmosphere of the red giant sun creates enormous drag. Earth may begin spiraling inward, slowly, inexorably, toward the star. Different models produce different outcomes. Some predict Earth survives as a burned, lifeless rock. Others suggest our planet ultimately plunges into the sun's outer layers and is destroyed. And here's the unsettling part. Even if Earth survives physically, it will already have become completely uninhabitable billions of years earlier. The debate isn't really about saving life. It's about whether the planet itself remains. Imagine standing on Earth during the final stages. The oceans are gone. Riverbeds lie empty. The atmosphere is thin and unstable. The sky glows with an eerie brightness. The sun appears enormous, perhaps dozens of times larger than today. Surface temperatures soar beyond anything humans have ever experienced. Rocks begin melting. The crust itself changes. The entire planet becomes a furnace. At this point, Earth no longer resembles the blue world we know. No forests, no clouds, no waves crashing against shorelines. Only heat, silence, and a giant red star dominating the heavens.
Then comes the final chapter. If Earth is engulfed, the atmosphere disappears first. The surface vaporizes. The planet breaks apart. What once hosted oceans, mountains, civilizations, art, science, and history becomes nothing more than material absorbed into the sun. A cosmic recycling process. The atoms remain, but Earth itself is gone.
Surprisingly, the sun still isn't finished. Eventually, even the red giant phase comes to an end. The star begins shedding its outer layers. Massive shells of gas drift into space. They create glowing clouds known as planetary nebulae. Despite the name, they have nothing to do with planets. These nebulae are among the most beautiful objects in the universe. Expanding bubbles of colorful gas illuminated by the dying core of the star. For a brief cosmic moment, the sun may become more beautiful than ever before. Then, the remaining core is exposed. What remains is something called a white dwarf. The white dwarf is the sun's final form. Imagine squeezing a mass comparable to the sun into an object roughly the size of Earth. The result is incredibly dense. A teaspoon of white dwarf material would weigh tons. No nuclear fusion remains. No new energy is produced. The white dwarf simply glows with leftover heat, like a fireplace after the flames have gone out, slowly cooling, slowly fading. Over billions and trillions of years, it radiates away its remaining energy. The brilliant star that once illuminated an entire planetary system becomes a dim stellar ember, a silent monument to a life that lasted nearly 10 billion years. At first, this story sounds depressing. The death of Earth, the death of the sun, the end of everything familiar. But astronomy offers a different perspective. Nothing truly lasts forever. Not stars, not planets, not galaxies. The universe is built on cycles. Stars die, their material spreads into space. New stars form, new planets emerge, new possibilities appear. The atoms inside your body were forged in ancient stars that died long before the sun was born. In a sense, we exist because other stars reached their endings. The sun's death will eventually contribute to future cosmic beginnings.
And that leaves us with one final question. What happens before the sun's end? Humanity still has billions of years, an almost unimaginable amount of time. Could future civilizations move Earth outward? Could they build artificial worlds? Could they leave the solar system entirely? Or will nobody be here to witness the sun's final transformation? We don't know. And that's what makes this story so fascinating. The death of the sun is one of the few cosmic events we know is coming, yet the fate of those who might see it remains completely unwritten. Somewhere 5 billion years in the future, a giant red star will rise over the remains of our world. Whether anyone is there to watch is a mystery that has not been solved yet.